So picking up where we left off with linear equations, in our previous lesson we talked about how to find the slope of a line through 2 points using the formula for slope. We also talked about how to write the equation for a line knowing first what the slope of a line is and a point that it goes through. And we also got into looking at how you find the equation of a line through 2 points where the slope is unknown. So before we kind of move forward with some other types of lines involving writing equations and slope and things like that, just wanted to kind of recap just some of the different ways to write the equation for a line. So a couple different things here. First is we've been focusing primarily with the slope-intercept form of the equation of a line, and there's also this what's known as the general form for the equation of a line, and that's where basically the equation of the line equals 0 at the end. We also have the equation for a vertical line where the slope is undefined, and that's x equals a, where a is the x-intercept. We also have the equation for a horizontal line, and that's y equals b, where b is the y-intercept. And then, hopefully this is familiar to you since we've been talking about this last couple days, and that is the slope-intercept form, y equals mx plus b. Slope-intercept form is by and large the easiest way to write the equation for a line. So some things involving equations of lines with, first we'll talk about parallel lines. So what we have here is if two lines are parallel, then their slopes are equal. So you have this here. Parallel lines have slopes that are the same. So the example that I have here for you is there's two lines here, y equals 2x plus 3, y equals 2x minus 4. And the reason these lines are parallel is because they both share the same slope. They both have a slope that equals 2. So one of the things we're going to look at today is how to write the equation for a line that is parallel to a given line. The other thing is perpendicular lines. So perpendicular lines are, just by definition, two lines that intersect and form a right angle. And what we know is true about perpendicular lines in regards to their slopes is perpendicular lines have slopes that are known as negative reciprocals. So there's two things that are involved with negative reciprocals in regards to slope. The negative part of negative reciprocal means that the two slopes have to be different signs. One has to be positive, one has to be negative. And the reciprocal part of this is, if you recall when we talked about some different things with fraction, basically to find the reciprocal of a number, you just take it and flip it. So for instance, if we're just talking reciprocals, if I gave you 2/3, let's say, right, the reciprocal for that would be 3/2. So the example I gave you here, I have two lines, y equals negative 1/2 x minus 1, y equals 2x plus 3. So notice that the slope for this first line is negative 1/2, the slope for the second line is positive 2. And the reason these lines are perpendicular is because of two things. One, and both of these need to be true. You have one slope that's negative, which is what this one is here. You have one slope that's positive, which is what this one is here. So that sort of speaks to the negative part of the negative reciprocal. The signs have to be one positive, one negative. And then if you take 1/2 and you flip it, I take 1/2 and flip it, right, I get 2/1, right, and 2 divided by 1 is 2. So that's what makes these two lines perpendicular. Their slopes are negative reciprocals. So let's talk about some examples with this. So the first one is this here, and the question says, find the slope-intercept form of the equation of the lines that pass through the point 2, -1, and are parallel to, that's part A, and perpendicular to, that's part B, to the line 2x minus 3y equals 6. So a couple things here. First is, I want to take this equation, this 2x minus 3y equals 6, and I first want to put this in slope-intercept form. And the reason I'm doing that is that's just going to be a lot easier to work with than leaving it in this type of form here. So to put this in y equals form, first I want to minus 2x on both sides, so I get negative 3y equals 6 minus 2x. And then from here I want to divide everything by negative 3. So just keep in mind when you do this, everything gets divided by negative 3. And when I do that, I get y equals 6 divided by negative 3 is negative 2. And then notice here, negative 2x over negative 3. So first thing is this. Notice that I'm dividing a negative by a negative. So because of that, this is going to be positive, so I'm going to have a plus there. And since 2 divided by 3 doesn't divide evenly, we're just going to leave this as 2/3. So just remember, we're talking about slope and graphing and things like that. It's better to leave your slope as a fraction as opposed to a decimal, in particular, a decimal that you'd have to round to get the answer to. So what we're basically looking for in this problem is, if you take a look at part A, the whole business of parallel. So this line, y equals negative 2 plus 2/3 x, this line has an infinite amount of lines that it's parallel to, but only one of those lines is parallel and goes through that point right there. And that's basically what I'm looking to find when I find the line that's parallel to this. So if we're talking about using slope-intercept form in order to do that, so here's part A. So just as we talked about before, I'm going to start off with this first, which is the M in the B box, because these are the two things that I gotta know in order to write the equation for the line. So if you have this equation here in slope-intercept form as y equals negative 2 plus 2/3 x, and we're talking about the line that's parallel to this, well, the slope of this original line is 2/3. And what we know is that any line that would be parallel to this line here would also have to have a slope of 2/3. So I'm going to fill that in here. And when I do that, now I know what the slope is. So all I'm left to figure out here is what's the value of b, what's the y-intercept. So in order to do that, I'm going to go to y equals mx plus b. And now this is going to look very similar to what we did yesterday with finding the y-intercept. So I'm now going to substitute some values in here. So I'm going to put a 2/3 in for m. I'm going to put this 2 here. I'm going to put that in for x. And then I'm going to take this negative y and I'm going to put that in here. And when I do that, I get negative 1 equals 2/3 times 2 plus b. So when I multiply 2/3 times 2, right, I get negative 1 equals, this would be 4/3 plus b. And then I'm going to minus 4/3 on both sides, and when I do that, I get negative 7/3 is the value of b. So that's going to go here. Now I can write the equation for the line because I know both the slope and the y-intercept. So this is going to be y equals 2/3 x minus 7/3. That's the equation of the line that is parallel to this here and goes through this point. So how do I know if I'm right? How do I know if in fact the equation for this line, this 2/3 x, this y equals 2/3 x minus 7/3, how do I know if it really is parallel to the original equation and goes through that point? So if I exit out of here and let me go to my calculator. So I'm looking to check two things, but first let me sort of input what I need to do here. So if I go to y equals, I want to put in what we said the original equation was, negative 2 plus 2/3 x. And then I want to put next what we said the line that's parallel to this is. So I got 2/3 x minus 7/3. And I'm looking to basically check two things. One is, when I graph this, do I get two lines that appear to be parallel? So here's the first line, here's the second line. Very close together, but I think you guys can see here, these two lines run side by side, they never intersect, so that's what makes them parallel. But now what I want to check is, if I go to my table, what I'm looking for is, does the second line, does the line that I put in y2, does it go through the point to negative 1? So if you look here, here's x is 2, here's y is negative 1, so I'm good there. So that's just something I can do to check to see if the equation that I have does in fact meet the conditions of the problem. So That's the perpendicular part of this, or the parallel part of this. What about the perpendicular part? So I got the same point, I got the same equation, but I'm looking for the equation of a line that is now perpendicular to this original line. So remember, we talked about this line in slope-intercept form, and that would be y equals -2 plus 2/3 x. So I'm still going to come back to my M and B box. So the slope of this original line is once again 2/3. And what we know about lines that are perpendicular is they have slopes that are negative reciprocals. So if I want to know what the negative reciprocal of 2/3 is, remember I got to do two things. First, I got to change its sign. So since the original slope is positive, the slope of the line that's perpendicular to this is going to be negative. So let me start with that. And then the reciprocal part, I want to take 2/3 and I'm going to make it 3/2. So this right here is the slope of the line that is perpendicular to this original line that we have. So I'm going to put that in here, -3/2. Now I just want to find what the value of the y-intercept is. So once again, I'm coming back to this, y equals mx plus b. And I'm going to substitute in a -3/2 for m. I'm going to put a -1 in for y. I'm going to put a +2 in for x. And when I do that, here's what it looks like. I get -1 equals -3/2 times 2 plus b. So when I do -3/2 times 2, right, I get -1 equals -3/2 times 2 would be -3 plus b. So when I solve this, I add 3 to both sides. I get b equals 2. So that goes here. Now I have enough information to write the equation for the line. So this is going to be y equals -3/2 x plus 2 at the end. And that's the equation of the line that is perpendicular to the original line that we had. So how do you know if you're right? So we're going to go back and once again take a look at some things in the calculator. Two things actually. We're going to check to see, number one, do the lines appear to be perpendicular? And does this second line go through the point 2, -1? So I'm going to come back to y equals. Let me leave the original equation here in y1. But in y2, I'm going to clear this out and I'm going to put the new equation in, which was -3/2, -3 divided by 2x plus 2 at the end. And then I'm going to graph this. So what I'm looking for when I graph this is, do I get two lines that appear to be perpendicular? So here's the first line. And did I forget to put a negative in here? Yes, I did. So remember, this is -3/2. So let me come down here and insert a negative. So one of the things that I noticed when I did that graph right there was because the line was moving in an upwards direction as it was moving from left to right, I knew the slope of that couldn't be right since I knew the slope for this had to be negative. So here's the original line again, and here's the second line coming through there. So one of the things that gets kind of tough to see when you're looking at this is how the two lines sometimes don't always appear to be perpendicular. So one of the things that I would suggest you do with this, if you get two lines and they appear to not be perpendicular, is just make sure you go back and check your slopes and just make sure that you have two slopes that are negative reciprocals. And then from there, what I want to do is I want to go to the table and I just want to check to make sure that this second line, this y2, goes through the point 2, -1, which in this case it does. So I know I have that part taken care of there. So that's kind of some of the things that we do with the parallel lines and perpendicular lines and slope and things like that. So wanted to kind of finish up with this, and this is just another sort of application type question involving slope and y-intercept. So the question here says, your publishing company has purchased a $12,000 machine that has a useful life for 8 years. the salvage value at the end of 8 years is $2,000, meaning you're purchasing this for $12,000, but at the end of 8 years, its estimated value is about $2,000. And the question says to write a linear equation that describes the book value of the machine each year. So what I want to do is I want to basically take this information, this here and this here, and I want to create 2 points out of this. So one point is going to be this. When the machine is 0 years old, its value is $12,000. That's one point. And when the machine is 8 years old, the value of it is $2,000. So what I want to do is I want to create an M and B box again to find what the slope and y-intercept is through these 2 points. So in order to do that, I got to find the slope first. So this is going to be y1 minus y2, which will be 12,000 minus 2,000 over 0 minus 8. So when I work this out, 12,000 minus 2,000 is 10,000 over negative 8. And then what I want to look to do here is I want to divide that out. So we've talked before about making sure when you go to do your division here that if something doesn't divide evenly, leaving it as a fraction, but if it does divide evenly, which in this case this does, make sure we have it so it divides evenly. So the 10,000 divided by negative 8 is negative 1,250. So that's the value of the slope. Now I just want to find what the y-intercept is. So in order to do that, I got y equals mx plus b, and I'm going to substitute in a negative 1250. I'm going to put that in for m, and then I'm going to pick one of these 2 points, doesn't matter which one. I'm actually going to go with the first one since it's got a 0 in there. It might be a little bit easier to work with. I'm going to put that 0 in for x, and I'm going to put this 12,000 in for y. So when I do that, I get 12,000 equals negative 1250 times 0 plus b. So when I work this out, negative 1250 times 0 is 0, so the value of b is just 12,000. So that's the value of b. So the equation for this would be, I'm running out of room, I'm going to try and sneak this in right over here. I got y equals negative 1,250x plus 12,000. That right there. And the significance of the equation is, if I wanted to know, let's just say, how much the machine was worth after 3 years, what I could do with this equation, not that the question's asking you to do that, but what I could do is I could take this x and I could substitute a 3 in for it, and that would tell me what the value of the machine was at the end of 3 years, or at the end of 4 years, or 5 years, depending upon what it was I was looking to find out the value therefore. So that basically concludes what we've done up to this point with equations of lines. So just keep in mind when you're talking about equations of lines, one of the most important thing to know when you're writing the equation for a line is you got to know what the slope of the line is. That's the most important thing to know, and once you know the slope, you can always use the slope to find the value of the y-intercept.